I have here a coil of copper wire. And I'm going to look closer and show you this part of it. All right, so you see there's a little wire here, and that wire is connected to this red terminal, and it loops around and around and around, and then the other end of the wire is here, and that connects to this black terminal. The wire itself is copper, but it's coated with an insulating material. So even though the wires are right next to each other, they're not conducting in that direction. The current can only go in a long direction in the wire, so it has to go around and around and around. And you see there's space in between. There's a magnet that's in here for other purposes. Doesn't matter for us. I just want to show you I have this coil of wire. And now I have to do this really awkward thing, like barely almost close my laptop. Here is a meter, a galvanometer. See the galvanometer? I think you can see it.
Yep.
So there's a needle here, and when a current is put into these terminals, so it goes in one and comes out the other, this needle will deflect. It'll deflect one way or the other depending on which way the current goes. So what I'm going to do is I'm going to connect the wires coming out of this to my loops of wire here. So red into red here, it doesn't really matter, but red into red because of OCD, I guess. And the black into black. And you see nothing is happening. All right, so I have this thing set up like this. I think you can see it. You see my nose. My nose looks huge. Get that out of the picture. Okay, so galvanometer is going to tell us whether there's a current in the wire or not. Loops of wire. And then I have a magnet on a stick. There it is. So there's a magnet, and it's taped to the stick so that I can, hold it up. And so that's a magnet. And now what I'm going to do is stick the magnet into the coil. Did you see what happened? As the magnet went in, there was a deflection of the wire. I'm going to pull the magnet out. And the deflection of this little needle moves again. That indicates that there's a current flowing in the wire. And the current only flows as the magnet is going in, or coming out. If it goes in, there's a current as it's going in, but once it's in and not moving, it's not doing anything. It's wiggling a little bit because I can't hold it still, basically. And if I pull it out, there's a deflection, but then the magnet is still, and then nothing happens. Notice also that if I do it faster, there's a bigger deflection. And if I do it slowly, that's slow, and this is fast. Don't collide there. Have you guys seen this before? Did you do this in a lab, or did you do this in elementary school or something?
We didn't do it in lab.
Okay. No, okay, so you've never seen this.
And then other knows in chat.
Okay, I see. All right, so I'm glad to show this. This is real. I mean, it's so easy to read about this in the book, especially on online format, and think it's so abstract. It's real, folks. It really happens. And here's the proof. I would, if we were in person, I'd pass this around so you could play with it. All right. It's basically an electromagnet in reverse, right? You probably made electromagnets. You took a coil of wire, you hooked a battery to it. And then the magnet on the inside, this compass here, deflects. You probably did that. This is in reverse. We're putting in the changing magnetic field, and we're creating a current.